Okay, so here's a projectile motion problem. It's not quite so trivial, right? We've got a cliff, right? It's 78.5 meters tall, so that's this distance here, right, from there to there. And then we're shooting it up at an angle, so it won't be just a simple horizontal projection problem, right? And so the first thing to do, and they give us clues here, right, is we're going to find these vector components here. Okay, so we're going to find what this guy is here. Right, this is going to be our x component of the velocity, and then this will be our y component, right? This is the opposite side, that's the adjacent, right? So the adjacent side is going to be 126, that's the hypotenuse is 126, right? Cos of 43, right? So 126 cos is 126 cos 43. I just made sure I was in degrees, right? Okay, that is 92.151 meters per second. And that's in the x direction, right? And then our opposite side is going to be 126 sine 43, right? So 126 sine 43. I'm going to store that guy too. Let's see, that's 85.932. 85.932 meters per second. This is in the y direction. These will become our initial velocities, right? So the next thing to do is to do one of these giant tables, right? So horizontal, vertical, S, U, V, A, T, S, U, right? And then our acceleration vertically is negative 9.81. Our initial velocities, we're just going to get these guys from we're going to get them from down here, right? So this is 92.151 is our x, right? Meters per second, and then this one is 85.932. Right, and that's our vertical one, right? That's this side. Okay, and then our final horizontally is the same, 92.151. Acceleration is 0. And then there really is nothing we can do here because there's really this guy, these guys, and this guy, and we don't know two of those. But I do believe, let's see. Oh, our S, we can figure that out, right? This is, we displace ourselves when we go here to here, right? We're going to go down 78.5, right? Okay, now notice that we're going to go up and then we're going to go down, but remember displacement S is the net change in position. And in this case, it's vertical, so the net vertical change in position is that we will go down 78.5, right? So I think now what we want to do is solving for t right now is quadratic, I do believe. So I'm going to wimp out and solve for v. So v squared is u squared plus 2as. So v is the square root of 85.932 squared plus 2 times negative 9.81 times negative 78.5, right? Don't forget the negative. Okay, so let's see. And I'm going to use the exact value of this, so if you're using this rounded value, you might be slightly off of me, but who knows. Okay, so let's see. Alpha b squared plus 2 times negative 9.81 times negative 78.5. I trust this calculator will get this right. 94.469. Okay, that's our final velocity, but that's the absolute value of it. To be sure, this thing is going to be going down when it strikes the ground, so it's definitely, the final velocity will be negative 94.469, right? So that's, you got to insert your intelligence there, right? Minus 94.469 meters per second, right? And then let's see, okay, now we can find time. We can use v equals u plus at, right? So negative 94.469 equals 85.932 plus negative 9.81 times t, right? So if you miss this minus sign, then you get, of course, a very short time. But let's see. Okay, so that, hold on here, that, okay, divided by 9.81. I'm getting that the time is 18.3895 seconds. I'm going to store that in t, right? Okay, and then that's the time on this side, so it's 18.3895 seconds, right? And now we can figure out s. S is just ut, right? So it's going to be 92.151 times 18.3895, right? This is s equals ut. It's really plus 1/2 at squared, but a is 0, right? Okay, so that guy times, and I got 1694. Columbus sailed right out the door. 1694 is our distance. Right, so how far did it go? Well, with 3 sig figs, I guess you'd say 1690, right? I'm going to be a rebel and say 1694 meters. So 1.7 kilometers, right? And then we're going to find the velocity of impact in angle magnitude notation. So to do that, I've got to take these guys and draw a picture of that final velocity and then find an angle magnitude, right? So over 92 down 94.469, right? This is 92.151, right? And then we're going to find the hypotenuse and then that angle, right? The hypotenuse will be, let's see, 94. Hypotenuse will be the square root of 94.469 squared, okay, plus 92 squared. Here I am just using the rounded values, right? And I'm getting 132 meters per second, right? I must have used a different value there. 132 meters per second. For that, and then this this angle right there is going to be inverse tan of the opposite 94.469 over 92.151. So inverse tan of 94.469 divided by 92.151. And that's 45.7 degrees. Unless I made some mistake somewhere, right? So this would be your speed of impact, right? This would be the angle below that. And there it is.